Good afternoon, everyone. Today we're in a video on tables of values, and namely we're going to look at a table of values. We're going to get the equation for this function that would give us this table of values, and we're going to plot the points onto a graph so we can kind of see what it looks like. So when we look at a table of values, we namely look for two things. We look for how much the y values are changing every time the x values go up by 1. Now this is conveniently drawn out, and oftentimes this is what it looks like. So as x goes up by 1 every time, the values of y change by how much? Well, the difference in each successive term is an addition of 3, right? From one y value to the next, we're simply adding 3 every time. And so what that tells us is our equation for y in terms of x. Again, x is our independent variable. So x is kind of leading the way. That's why we get to pick whatever x values we want to look at. And then y is our dependent variable. Okay? Y, the dependent variable, is always on the vertical axis, and likewise the independent variable x is always on the horizontal axis. Okay? Always. Now, once we've established that the change in every successive y value is 3, insinuating that the values of y increase by 3 every time the values of x increase by 1, that means that our equation for y in terms of x is going to start with a term of 3x. Okay? 3 times x. Another way of saying it is y increases 3 times as fast as the x values, and we can see that clearly in our tables of values. As x increases by 1, these x values are all increasing by 1. The correlated y values are increasing by 3. And so the y values are increasing 3 times as fast as the x values. That's an easy way to remind yourselves of how this works. And then we often get a constant term afterwards. The constant term is simply the term that is constant and always the same, the term that does not vary no matter what the value of our independent variable might be. And that's precisely the value when x is equal to 0. Because when x is equal to 0, this term, this variable term, becomes 3 times 0, and 0 times anything, so no matter what the coefficient may be, 0 times anything is 0. So that term goes away, and all we're left with is this constant term. So the constant term is precisely the y value when x is equal to 0. Okay? And so we get minus 1. And here is our linear equation. Okay? Again, we call these linear equations. Okay? Because the biggest exponent on any terms with x is, this is an x to the power of 1. Okay, when there's no exponent, that's x to the power of 1. Eventually you will see equations with x to the power of 2, x to the power of 3, so on and so forth. And you'll deal with those in the future. But for now, we're simply looking at equations where the biggest term involving x is an x to the power of 1 term, and these are linear equations, okay? And again, the first part of the word linear is line, and that's why the points line up next to a graph, okay? The connections you might want to make in your head. And so now let's just look at the 2 parts of the equation that we discussed. However much faster the y values increase compared to the x values, this number in front of the x that we said, the 3 times as fast, this 3 is called the coefficient of x. Coefficient of x. Okay? So again, it tells us how much faster the y values increase relative to the x values, and that's our coefficient of x. And then the second part, this minus 1 term, is the constant term. Use the regular French here. Constant term. Again, because it's constant, it's always negative 1. It doesn't matter what the value of x is, this is always minus 1 because there's no x's here. Right? And we see it pop up always when x is equal to 0, when x is equal to 0, y is negative 1, hence the constant term. And now, if we go ahead and plot these 5 points, it's typically 5 points that we go with, no matter what kind of graph we're looking at, to be honest with you. If we go ahead and plot these 5 points on our graph, -2, -7, reminding you that any point on a graph has coordinates x, y, and so x, y, -2, -7, that will be x, -2, y -7, so that's roughly around here, right? -7 for y, -2 for x. Let's pop the coordinates since this is relatively new. The next point is going to be a -1 and -4, -1 for x, -4 for y, x -1, y -4, that is here, -1, -4. Next we have 0, -1, 0 in x, it's here, and -1 in y, it's roughly here, 0, -1, that's our constant term, okay, that's our constant term. This is something we're going to see later on in math. You'll refer to this point as the y-intercept, okay, because this is the point where our function intercepts the y-axis, okay? Y-axis intercepts a line right at this point, crosses the line at this point. The next 2 points are 1, 2, and so 1, 2, and finally our 5th point will be at 2, 5, somewhere around here. Okay. Now we could plot more points if we wanted to, if we wanted a bigger graph with more data on it, but 5 points usually suffices, especially for linear equations that are fairly straightforward. And so now let's assume that this is continuous data. We could go ahead and draw a line through these points. We add arrows on both sides, signifying that it goes on forever and ever, indefinitely on both sides. And again, highlighting the idea that we call them linear functions because the word line implies that the points line up nicely when they're plotted on a graph. Okay, so those are the key points that I would say are most important when looking at linear equations, their tables of values, their equations, and their graphs. I hope this helps. If you guys have any comments, suggestions, please let me know. Thanks for watching, and have a great day.